Okay, year 12, so we are looking at that tricky question from the summative assessment, question 6, part B. And it was the field, the triangular field with the ratio of size, 15 to 15 to 15 root 2. And we were trying to find if the rope was replaced and Gertie could graze exactly 90% of this field, what would how can we satisfy the equation that would create not knowing the length b? Okay, so first of all we have a triangular field, and then if this length b goes beyond the field, I'm sure you figured this bit out. The actual circular part of it is some of it's going to be outside the realms of the field if it was, and that these two areas would be not grazed, and this bit in the middle would be 90% of the field, so I'm sure you got that. So to start off with, from part A, 90% of the area was the 101.25, which you got from part A. This is from part A. Okay, so that is any of the equations, so that is what that area equals to. But how do we form the rest of the equation? Well, we know some things about this triangle anyway. That's 15 from here to here. It's also 15. This long length here is 15 root 2. Let's label these corners. What do I have? This I call this O. This is A. E. You'll see why I've done that in a second. Let's split points along this. I'm going to split up this area. First thing, I'm going to split it up into two smaller triangles and work off either side. This is one stage. I also want to split it off into make 4 areas. Then I'm going to find the areas of for this 90%. 2 triangles and 2 arcs. Okay, they will both be symmetrical. So where are these positions? This would be, let's say, B. This is D. When I refer to them from now on. So let's get started. Let's do some things that we can save for sure. Let's have a little look. One of those. AC is where I went first. So this length from here to here. That would be half of the total. So let's say AC is equal to 15 root 2 over 2. Hopefully that makes sense. And also then EC will be the same, which would be from here to here. That's EC. Let's say EC also equals that. AC. There's one more length that would be the same as that, and that is OC, which is going to be a very crucial part. So from O to C, using you can use Pythagoras theorem to get that. If you know that's 15 root 2, or you can just use the fact that lossless triangle. So OC, it's also equal to that, so we've got lots of information there. Let's have another look. OB then would be at this extended point of the length. So B, remember from the question, was between 10 and 15 meters. At this point is the point where it starts going outside the circle. So that is going to be the length B, whatever B is. OB is going to be B. Alright, so the OD. And then the last thing we probably need to find for this is, if we're using this triangle, we need to find the BC length. So that BC length can be found, well, if I know, let's just switch colors for a second. If I know that this length is B, and this length is 15 root 2 over 2, I can use Pythagoras theorem, so I know that this is a right angle here. Pythagoras theorem would get me squared, this squared minus that squared square root. So that would be square root of b squared minus, what was it, 225, it works out as, you can 225 over 2. Okay. I left it like that because you may see that in the answer they want 225 over 2, and that's where that comes from. Okay, so we have, put it in on the diagram since we have it. Okay, so I think we're equipped with enough to start thinking about some of the areas, but what would be really useful is if we had an angle to work off. But because we have some right angle triangles, of course we do have an angle to work off. Let's call this angle here theta. Right, so what is theta? Let's just look at theta. Well, you can use sine or cos to get a ratio and get theta. Because the answer looks for cos, let's go with cos theta. Using this right angle triangle, cos theta would be 15 root 2, which is the adjacent side, over hypotenuse, sorry, 15 root 2 over 2, over the hypotenuse. Rearrange that a little bit and you get 15 root 2 over 2b. Okay, so that's cos theta. Now we want theta, not cos theta, so it would be arc cos 15 root 2 over 2b. That would be that angle here, and that angle there. Alright, so we're equipped, I think, now with everything we need to know to get the 4 areas using formulas. So let's start doing that. Let's start with the area of the sector. I'm just looking at the way the answer needs to be written. So we'll have an area of this. I'll look at this area here. Should have used a different color. Let's have a look at this area here. So there's 2 of them. They're going to be the same because of the symmetricness of this triangle. So let's look at that. It will be twice half OB squared, so that would be B squared. This and this are going to be the same length, so a half B squared. Okay, everything looking good so far. Multiplied by the angle. Now, what is this angle then? This angle here. Well, we know that entire angle has to be 45 degrees because you just split 90 in 2 to get that. We don't know theta. We do know theta. But we do know then that we can construct that angle to be, well, this bit would be 45 degrees, take away theta. So pi over 4, take away whatever theta is. Now we worked out theta here to be arc cos 15 over 2. Okay, is that looking like my answer? It is. Okay. Alright. That's still on the screen yet. Alright, so that is the 2 sectors here. That one and that one. That's why I multiplied it by 2. Okay. Now I get the area of the triangle and add that on, so that would be twice again, twice a half, and it's just going to be base times height for this. So OC, OB. So it's going to be a half times, which way did they put in the answer? 15 root 2 over 2. So this side times this side. Root b squared minus 225 over 2. Beautiful. Okay, so these can go away. 2 times half. And let's finish with our final line. B squared times pi over 4 minus arc cos 15 root 2 over 2b plus 15 root 2 over 2 times the square root of b squared minus 225 over 2 equals the area of 1.2. think that. Okay, so that's the answer to part B. Quite tricky. I think the hardest part might have been finding the angle, perhaps. But yeah, so set it up. The diagram was absolutely key. And the fact that it was symmetrical. This was 45 degrees. Take away theta. To find theta, you wanted cos. You could have used sine, but you wanted cos. And so we did. Okay, and that's that.